All right, we are looking at an application problem today. And we're on page 91, and it is volume and surface area. All right, so we have a cylindrical container, and it has a diameter of 6 inches. We're really not going to use the diameter. What are we going to use? Radius. We're going to use the radius. So let's just start with that. The radius is 3. Okay, and this is the height of your cylinder, which is 1.5 feet. Now, slow your roll. I want you to look at this. The radius is 3 inches and the height is 1.5 feet. Does that bother anyone? Yeah. It should. It should all be the same label, same unit. Wow, that was rough. Okay, so what is the height in inches of the container? So it's going to step us through it. The first thing is, what is the height? Well, how many inches are in a foot? 12 inches. So 1 foot equals 12 inches. So I'm going to take my 1.5 feet and I'm going to multiply that by 12 inches in 1 foot. Now, I don't need to show all of that, but I really think sometimes it helps. It's 1.5 feet. Look, the feet cancel, and 1.5 times 12 gives me what? I'm going to go with 18 inches, but you should double check my math. Anybody agree with my 18 inches? Good enough. No, it should be correct. Now, to the nearest hundredth, what is the volume? Okay, looking at your formula sheet, what was the formula for volume? Volume is pi r squared. So that's the area of the base times what? The height. So I'll let you fill it in, but remember, you're going to use 18 inches for the height and 3 inches for the radius. So 3-inch radius, 18 inches for the height. Here is your volume formula, okay? Now, if you look at this, it says Erica filled the container with 250 cubic inches of sand. Cubic inches is the same as me saying 250 inches cubed. What is the approximate height in inches of the sand that Erica put in the container? So you're doing two different things. You are looking at the volume of the container, and then you're saying, hey, this is how much sand went in there. So if you reverse this, I actually don't need to know this formula, but if I can think about this container, you don't have to draw it, but here's my container. The volume is 250 inches cubed. So picture her pouring something in here. This much of the container is filled up with 250 inches cubed. So picture those little cubes there. I want to know what is the height that the sand hits. So what's the radius of this container? It's still what? 3. So you're going to do your formula, volume equals pi r squared times height. And you're going to say, hey, the volume's 250, pi, the radius is 3 inches, but we're looking for the height. And then we'll get an approximate answer to the nearest hundredth, so you can go ahead and put that pi in your calculator. I would clean this up first, pi times 3 squared, and then divide it. So you're going to find the height of the sand. So the height of the container we know is 18 inches. We want to know how tall the sand is in there. Okay, now flip it over. So I pretty much got that well started for you. This is an oblique cylinder. We talked about this 2 days in a row. What's the difference between an oblique and a right cylinder? Yeah. So an oblique cylinder is pushed to the side. I don't want the slant height. I do want this height. That's what it is. I want the height from top to bottom, not the slant height. So they gave me what I needed. The height is 4. If you're looking at a triangular pyramid or a square pyramid and I need the surface area, that's when I need the slant height. Okay. So this is asking for the area of the base. Show your work. To the nearest hundredth, what is the volume? So they're basically just stepping you through this. So the area of the base is just pi r squared. And when you go to do the volume, you're taking that area of the base times the height. Okay. All right, last one on here. You have a right cylinder with a diameter of 9. Okay, well, it's important to know the diameter for using this right triangle. But if I'm doing this work, if the diameter is 9, what's the radius? 4.5, right? 4.5 centimeters. So I want to use the radius when I do this. But it says, what's the area of the base? Okay, we can do that. Use your radius. Area of the base is pi r squared. Now, it's nearest hundredth. What's the height? How do I find the height of this thing? We've seen this a couple times. See, it has a slant height of 15. They're calling this the slant height. I call that the diagonal. What'd you say? Pythagorean theorem. Yeah, when you set up your Pythagorean theorem, it is h squared plus 9 squared equals the hypotenuse squared. Now, once you know that information, you know the radius is 3. You're finding the height. Now find the volume. Okay? And that volume formula for the 50th time, pi r squared h. All right, so that should really get you started and your brain moving on these. All right, next idea. Flip it to the next page. And now we're talking about a what? What are we talking about here?
Rectangle.
Rectangular pyramid or prism? All right. So take a second, write down your form. All right, there's who is that? Come on. Nemo and Dory.
Is that Alfred, Nemo, and Dory?
No, it's black and white, bad photocopy of a picture. Nemo and Dory. Oh, Fred, Nemo and Dory. That's not nice. Look how she's looking at him. What fish has that big of eyes? It's that type of fish. That's Dory. All right. You guys are horrible. So, what is the volume in cubic inches of this aquarium? That's no problem. The volume is length times width times height. I was maybe doing some weird stuff the other day. You were doing length, width, height, and then, oh, was that you too, clowns? Yeah, you're doing length, width, height, and then multiplying by height again. The area of the base is length times width. And then you're multiplying that by the height. So I'm going to leave the parentheses out because I think that threw you off. All right, now, pay attention to this. When you do this, you're going to get inches cubed, right? That's volume. It says 1 gallon is equal to 231 inches cubed. How many gallons of water will the aquarium hold? All right, so every 1 gallon is 231 inches cubed. Isn't this like when we were painting a room and, 1 gallon covers 450 square feet? It's the idea that you're going to take your volume, whatever your volume is, and you're going to divide it by 231 inches cubed. And that is going to give you how many gallons it would take to fill this tank. Okay, now, next question is based on that. If 10 gallons of water were poured into the empty aquarium, what would the depth be? Oh, it's not based on that. So hopefully,
how do you do that?
Well, hopefully 10 gallons is not more than we need, okay? But if 10 gallons of water are poured in an empty aquarium, what would the depth be in inches of the water? So picture your tank again. I'm not going to draw as well as they did.
Definitely not a 10-gallon tank. So in 2 feet long.
Yeah, it would be. I mean, my daughter has a 10-gallon tank. It's smaller than you realize when you fill it up. Like, you're sitting here, or it's bigger than you realize. I'm sitting here filling it up, and you put 1 gallon in it, it's barely, like, covering the bottom of it. And hers is only a 10-gallon tank. So we know that it's going to be 12 inches by 24 inches, right? We are wondering what the height will be if we fill it with 10 gallons. Now, we do have to use this information. 1 gallon equals 231 inches cubed, right? How many gallons do we have?
10.
So we're going to have 10 gallons times this 231 inches cubed per 1 gallon. So the idea is the gallons are going to cancel out. And wouldn't that be 2,310 inches cubed? So for every 1 gallon, we get 231 inches cubed. We have 10 of them. This is my volume, guys. So you're going to have the volume. That's the volume. So you're going to have the volume equals length times width times height. So that's exactly how you would do it. 2310 is the volume with 10 gallons, not the volume of the tank. It's the volume with 10 gallons in it. And that equals your length times your width times your unknown height. So 12 times 24 times h. Wouldn't you take 12 times 24 and then get rid of it by dividing it? Oh, good. Is there a back? Oh, there's no back.
No, go back. Go back.
All right. I'm really excited about this.
Sam, I got